In case you're wondering what is currently happening on your screen, I'm doing an interpretive visual demonstration for a feature I'm going to add later this devlog. Yeah, I'm not the best at being subtle. The game I'm working on is currently called Project Drifter. It's my randomly generated, car-based, physics-based action roguelike, which is still in its very early stages of development, as you can probably see. So in today's devlog, the first thing I want to sort out is to finish the dungeon generation algorithm that creates the structure of the level, specifically the inner part of the rooms that I have already created. The features I've been adding over the past couple of weeks have built up to this, and the results have been awesome, so it's definitely been time well spent. At least, that's what I keep telling myself. A few devlogs ago, I talked for ages about the level generation in Spelunky and Nuclear Throne, and how that helped me to generate these fully interconnected rooms for a level. However, each room inside the level is just a very large perfect square of open space, with nothing interesting about it. You see no variation in the wall shapes, and you end up with these huge flat walls at the edge of a room that appear with no warning, and blap. I added these pseudo 3D looking walls for some additional depth in the game, but I ended up having to optimize them quite a bit. I wanted to maintain that aesthetic, but make a performant and not too memory intensive solution, which I feel like I achieved with quite a good level of success. The main technique that really helped with this is called frustum culling, or as I like to call it, can't see me, disappeary. With the 3D walls optimized, I now wanted to fill these giant open rooms with much more interesting and varied wall structures, without accidentally overfilling them and closing off the entrances and exits that connect the rooms. I found that it was keeping this connectedness while adding in new walls that proved to be a real head scratcher, to be perfectly honest. The method that provided the visual shapes I wanted for each room is called cellular automata. In a nutshell, you randomly place wall tiles around the room and then delete and add new ones based on wall density over several iterations to make a natural looking, almost cave-like system. The problem with this is that it's quite slow to run, and more importantly, it doesn't even guarantee any sort of connectedness when run in ideal circumstances, let alone my specific use case that needed the room entrances and exits left open to keep the rooms connected. One way I've seen people get around this is to track all the unconnected pods of space that form and then to just bulldoze between them. But I think that usually takes away from the natural look of cellular automata. Most other maze generators would end up just making even smaller rooms inside of the large rooms I've already made, which are more suited to travel through on foot than in cars and would be just moving the goalposts of the problem somewhere else. And it still didn't even take into account the added complexity of keeping the already defined entrances and exits of the rooms open. But then, a flash of lightning struck the dimly lit light bulb that is my head. Each room starts off with its exits defined by the initial spawning process, and within any given room, every exit must be reachable. There are 16 variations the exits in a room can take, depending on which of the top, bottom, left and right exits are open. For each of these variations, I defined the simplest path that just visits each of the exits in a straight line. However, this alone would be really boring. I don't want the player to just travel into a room and then in a straight line across to the other side of the room. So here's the really clever bit. I run an algorithm on every one of these simple paths that randomly picks a line segment of the path to be deformed by an arbitrary amount without breaking it. All we are doing is changing the shape of the line from A to B. I apply multiple deformations in a row to each of the paths to eventually get a very random and unpredictable route from one exit to the other. With this random wiggly route in place, we then expand it out wider at every point to make sure the cars can actually fit through it and it's not just one cell wide. The result is a more interesting but still fully connected layout for every room that ensures every other room in a level will still be reachable. The inner shapes of the rooms are also more organic and fun to drive around. This method ended up being really effective. It has become so satisfying to just generate a level and then just drive around it, seeing what unique features or shapes have been created automatically. I think due to the nature of the generation as well, there's a good mix between randomness and predictability. The random elements of the terrain keep the player vigilant so that they don't accidentally crash, but the more predictable nature of the initial path that's used to generate them means that they always have a general idea of which way they're trying to move. And now we get onto that terrible joke I tried to make in the intro. With the general terrain shape now sorted out, I thought it would be about time to put in some actual things into the levels to interact with. Now, if you have been here since a few devlogs ago, you'll remember that I have some basic AI and code to handle instances of enemy cars, and we'll get to those in a future devlog soon. First, I wanted to get something really basic in that will help us start adding things like vehicle HP, explosions, and damage. And I thought, what better thing to start off with than some good old-fashioned landmines? Here's why landmines are great for developers to implement. They're not great in real life. They don't move at all, so they are easy to test with, and they explode really violently, which is really fun. So we just add some mine objects into the game and then make them trigger a blast of physics impulses on nearby objects when they are touched. This sends cars flying and works really well, although it doesn't make much sense without an explosion effect. So how are we going to do the explosion? We could use a simple sprite animation like this, although I think that will get repetitive quite quickly, and I'm not good enough at art to create one that will look nice enough. No, instead I think our explosions will look best if they are generated dynamically. This will mean that every explosion will be different from the last, which is good because I'm planning on adding a lot of explosions into this game. The explosions I ended up creating are a combination of a few different particle effects. I initially followed a heartbeat tutorial to get an idea of how other people have made them before, but following the tutorial directly didn't really give the results that fit my game. After some tinkering and some adjustments to the way they work, I got an effect that suits Project Drifter way better. And when it's comboed with a bit of screen shake, it just fits the game perfectly. Now we just slap those explosion effects on the mines when they are hit and bang! Mines are looking pretty fine. I also added a rough implementation of HP to the cars so that they can be damaged when they're caught by an explosion, although I'm not 100% sure on how I want to represent health in the game yet, so that's still very much a work in progress. In the next devlog, I'm going to work on the enemy AI, because in its current state, it has, problems. And with that, if you're still here, thank you so much for watching this far into the video. It indicates to me that you quite like this type of content, and I generally try to put out a tutorial, a guide, a devlog, or a challenge video every single Friday, so subscribe for more of this stuff. Follow me on Twitter or even join my Discord server where you can ask me questions directly and I'm more than happy to try and answer them if I'm about. And that wraps up this video, so until next time, goodbye.